Okay, so I have the experiment for the second activity set up here. You can notice that, as I mentioned in the comments, you need, in the intro, is you need to have the light be just a little bit lower down than everything else. So I actually have a leaf that I took out of this table that I'm using to just offset it. If you have a piece of plywood or really anything that you can think of that might allow you to have the light, say, an inch lower down than everything else. So maybe that is just that you're mounting the light lower, or maybe it is that you are moving the ruler higher. So I've moved the ruler higher. But I could have also tried to find a way to mount the light lower. So, and the reason that is that you want everything on your rail to be at about the same height for this to work. Okay, so what I have here is the very first setup, and let's zoom out and see if I can get this to stay, maybe, so I can head over there. This may or may not cause my camera to just crash, but we'll see. That's pretty good. Okay, so I have placed the light sort of off of this. We're not interested in focusing the location of the light. We're interested in focusing this triangle made out of screen. So this is our object, and the position of the object is the number that you will read off of the meter stick here. So everything on that table that is a position is a number that you read off the meter stick. And remember, you need to make sure that you have everything with an uncertainty. And use your best judgment with that uncertainty. None of the uncertainties that you should be reading are the limits of the precision of the meter stick. They're all going to be quite a bit bigger. So I've tried to put my object as close to the end of the meter stick as I can. So I've got it at about 1 centimeter. And I want there to be 40 centimeters distance between the object and the lens. So if this position is 1 centimeter, I've put this position at 41 centimeters. And now, in this procedure, we are moving the location of the screen to find the location of an in-focus image. And as you move it back and forth, you will see that there's not just one image. So right around the focal length of the lens, I can get my in-focus image of the window because rays are coming in parallel to this lens. Will focus at the focal point of the lens, but that's not the image that we are interested in. We are interested in an in-focus image of the screen. So it should look like this. And if you have a hard time locating it, it is probably... Yes, Golden. Okay. So you will probably find, if you have a hard time finding this, it's probably because these things are at different heights, okay? Which is why it's important that all of these things be elevated about 1 inch higher. If you're not able to elevate your whole meter stick 1 inch, then try to elevate all of these things along the meter stick by 1 inch. So if you have like 1 inch tall object, that should work too. I was using an old cell phone before to raise it up a little bit. So I see my in-focus image right here, and let me move the camera so that I can zoom in on that for you. So you can see there's my in-focus image, and if I move it a little bit closer, now it's fuzzy, and if I move it farther away, it's in focus, it gets fuzzy again, but right in the middle, it's in focus. And you'll actually find that there's a range of values where you can call it in focus. So this would be a good way to estimate the uncertainty here. Right? As I wiggle it around this distance, it still looks pretty in focus to me. So that would be a way to estimate the uncertainty of the location of the in focus image. And in the rest of this data table, what you are going to be doing is moving the lens so that it is closer. So we're at 41 now. I'm going to move this back to 31. And so there it is. And now I'm looking for the new location of an in-focus image. Right? There's no longer an in-focus image there. But if I move this a little bit, now I find a new in focus image. If you need to measure the image height, which you do need to measure, you can measure the image height with this ruler here. So I'm just gonna put it so that the image is right there, and then I can read off of the meter stick or the ruler that I have here how tall it is. You might also, these cards don't need to come back to me, you might also use a pen or a pencil just to draw the limits, the height of the image, and then you can measure it later, and that would work too. And you might find, as I'm moving the lens again, so this is gonna get blurry, as you move even farther, even closer, move the lens again, that actually there's some spots on the table that are potentially off of the ruler, off of our meter stick. But you have this ruler here that should work just fine. So if you need to measure some things that are a little bit off of the meter stick, you can use this to add things to. So as you can see, probably under no circumstances should any of your uncertainties be the 0.1 meters or something like that, the limit of precision of the instrument. But because everything that we're doing here is pretty imprecise, and that's actually not an at-home thing. That would be true if we were doing this at our in lab as well. There's just a lot of imprecision to this. But so that is how you should complete activity 1-2.